Hey y'all, time for more of your favorite thing, Linux. We're gonna dive pretty deep today, and I'm gonna try to do as much explanation of absolutely everything as we possibly can. But I want y'all to remember that if you're not understanding something, or if you see something, or if I'm going over it too fast, or something like that, please feel free to come into WebEx or send me an email or just ask some questions. However, you can get a hold of me. And I'm happy to answer anything that's different between the two, between say Ubuntu or CentOS or OpenSUSE or any of that kind of thing. So yeah, feel free to reach out. All right, so we'll dive in. I'm gonna do most of my work in Ubuntu today. It seems to be the most performant of the VMs. So that's what I'll do in the interest of time. And I'm gonna show you another way to get even more performance out of it. Turns out we don't need the GUI, because every time you log into the GUI, unless I need you to use a web browser, it's useless RAM. It's wasted RAM. So we'll just work straight in the command line for most of this, and I'll show you how to get there. So follow along, and we'll meet in the command line. Anyway, so the topic today, or one of the topics today, is initializing the system. All right, we talked a little bit about booting and how that works, and grub and all that stuff. Well, grub hands off to the kernel, and we didn't really get too much further than that, other than to say, well, the system is booted now. Well, now we get to talk about what happens once grub hands off everything to the kernel, and yeah, what happens when you boot the system, at least a little bit. So if you run into really old versions of Linux, I guess, and by really old, I mean 2015 and before, that was really when a lot of the distributions made a changeover, you will see something called sysv init, this here. So Ubuntu took a different path at that time. They used a system called Upstart, but you really don't see a whole lot of 1404, 1504, any of those out there anymore, because 2104, I think, is coming out. So Ubuntu does something funny. This is a year. So say Ubuntu 1604, right? 16 is the year, 04 is the month. So 1604 was released in April of 2016. It's really easy to figure out, how old a version of Ubuntu is, as opposed to like Windows 7. When was that released? 2000 and what, 1? Maybe, I think. It's really, really old. But, the number doesn't give you any idea of where any of that came from. And same with Red Hat Enterprise Linux. 7, I don't even want to guess. 8 came out last year. 7 maybe 3 years prior to that, something like that. I don't know. And same with OpenSUSE. It's really hard to tell when they were released, but Ubuntu does a pretty good job of giving you that information straight out of the gate. So 1804, what we're using now, came out in April of 2018. So anyhow, the idea is 2015 and prior to that, you'll see this older system called sysv init. So let's talk about it for a minute. The very first process ID number, the very first thing that calls that the kernel calls, is process ID 1, and that's sysv init. And sysv init, or just init, is what will call everything else. Every application you run, every service that's run, every background process, everything is called by init. So if you were to go in and stop init, as in kill the process, everything would die, because init is the parent process to everything. And that means your graphical interface, everything, right? If you stop init, your system will, if it's smart enough, just reboot. So it can start up init. Init cannot start init without init being running. It's a weird Inception kind of thing. And again, that's why you just reboot. You get to start all the way over. So init uses this idea of init scripts. So these things are really complex a lot of times, and this is one of the simple ones. And this is a script to call cron. Cron D is a daemon being a process that waits in the background for something to happen. And in cron's case, that's chronological, right? As in, once a certain time threshold has come up, as in I want something to happen at 1 a.m. Once that threshold is met, cron will spring into action and do whatever it is that that's being asked of it at 1 a.m. So we'll dive into cron a whole lot more a little bit later. But right now, just know that cron is basically one big old timer, and it does whatever you tell it to do at that time, whatever that time is, whatever you dictate, 5 a.m., 5 p.m., and then it does whatever it is. And those things can be as complex as scripts like this to do, a million different things, or it can just be one thing, like, zip up this folder, and then you can have another service to move it to a network location an hour later or something like that. So anyhow, we've gotten away from really complex scripts like this because you had to really kind of prepare for any situation, right? What if it stops without telling you anything? What if a user tries to stop it? What if a super user restarts it? In every single one of those cases, you kind of have to have a fail-safe and figure out what it is that you want it to do in those cases. Well, that got real complex real fast, and in the interest of honestly sanity, we've moved to a different system. So the deal with this, though, is that you have to understand that init handles everything. If it starts, if something has a start, then init is the thing doing that thing. So be aware. That's where init is gonna come in. So in about 2016, I think everything moved over to a system called systemd. Before we get there, the last couple of things I want to talk about in it is these run levels. So you can do something. Let me get in the command line. I'll show you what I'm talking about. So you can run a command to basically tell init to run a lot of pre-configured scripts to get you to different places. Single user mode, multi-user mode with a GUI. There we go. Multi-user mode with a GUI. And don't worry, I'm recording it, so it'll be there just in case. Multi-user mode with a GUI. And these two, 3 and 5, should sound kind of familiar. Last time, I think it was, we installed a GUI and then moved to the GUI. We basically invoked the GUI so we could, click around on the screen. And then you have these. 0 will halt the system. 6 will reboot the system. And yeah, 2 and 4 are just not used. You, as a super user, can define what it is that you want 2 and 4 to do. So it's a little bit of room. You get a little bit of room to play in there. Now, here's the thing, though. You know how in Windows you have software from 1999 that still works in Windows 10? Yeah, Linux tends to do that too. So these inits, these init scripts right here, and real actual scripts that I showed you a second ago, those can still be run the same way they were run back in 2016 and before that. Pretty much every Linux system used some form of init prior to this. So I mean, we're talking back in the 80s when Unix was running around. sysv, by the way, comes from that terminology. System 5 is Unix terminology. So it's a very old system. And init is a very old system. So, I mean, you can imagine that if you did something for in one way for 25 years and all of the most popular Linux distributions decided, hey, you know what, we're going to do it a different way, you would likely not be too happy about your entire job changing, really. So there really was a lot of furor over the change. But anyway, the deal with this is that there were run levels, just like I mentioned here before, and you can still invoke them like this. And the way that you would do that is sudo init and, whatever. So sudo init 3 would drop us down to multi-user mode, which is really just command line interface, right? It unloads the GUI from memory, drops all that stuff out, and just puts you at a terminal. If you were in a terminal and you did sudo init 5, that would bring us up to the GUI. Now, the way that we did that before is not that way. We did systemctl isolate graphical.target. So that's a taste of the new system, what you did last week. So, yeah, that's really what this is about. And like I said, run level still works. Run level is basically querying the system for what run level am I at. And you can see is 5. So that corresponds to multi-user mode with a GUI. And we'll test it again here in a minute. I'm gonna set my default run level to multi-user because I pretty much never need the GUI. And if I do need the GUI, I will invoke the graphical interface to do so. Anyhow, that's the basics of init. You have these big init scripts. Init is always process ID 1. You'll see the same thing with systemd here in a minute. These are your run levels. And this is how you'll query it. This is how you'll set it. And this is how you'll configure the default. You really don't do this anymore, but on really, really old systems, you might find this as well. So the way that you would do that, I don't think it's there, but let's find out. And it's still there. Yeah, there's nothing in here. So if there were, what you would do, sudo nano or vi, but for now, we have not covered vi. There's a joke in Linux right now, well, forever, that the hardest thing to do in Linux is to exit vi. And vi is just a text editor, but it's true. I don't know how many people would just know that to get out of vi, so you can start typing and all this stuff, to get out of vi, once you make it into insert mode by accidentally pressing the I key, right? You hit escape, colon. If you don't want to save, you do Q exclamation point. If you do want to save, WQ. So this is like quit, and I believe it, and then right quit to save stuff. Right? I mean, it's not intuitive. It is not intuitive at all. And yeah, there's a running joke that it's impossible to get out. And I mean, if you're not familiar with it, that's probably pretty true. So for now, all of your text editing should be done in Nano. It is a lot more intuitive. It works like Notepad, and the commands that you need are down at the bottom. So what I wanted to show you real quick is etc init. Was it rc dash? Was it run level? Something like that, or sysinit. Sysinit.conf. Let's say it did exist. Oh, maybe it's in init tab. Let's see. Nope, I don't have that either. So init rc sysinit.conf. You would have this file, and it would have this in it: configure env default run level equals 5. Right? But again, since our system does not have init, that's hard. Sysv init installed. We use systemd. This file doesn't exist because it's not read. There's no point in having it. So on Nano, it tells you here, this little caret, the little house top, means control, and then this is the key that you press to do what it says. Oddly enough, write out means to save. But if you are familiar with any hotkey in any text editor at all, you know Control S, right? Control save. That's probably the best thing to do. So Control S. I actually don't want to do that. I don't want to save this file just in case it does something wonky to my system. I'm going to Control X, but Control S will save your changes and boot you out. So I do not want to save changes here. Anyway, so if you're on an old system, it's likely this file that will control your default run level. And usually it's just going to be, you're going to choose 3 or 5. Usually. If something goes horribly, horribly wrong and you know that you want to get into recovery mode, basically, you're going to make some changes, you'll set it to 1. But that's pretty rare. Only when catastrophic stuff happens do you want to set that. All right, so systemd. Fast forward to the future. 20 years in the future, 2016, everybody starts implementing systemd because, again, just sanity. If you saw that init script, yeah, and that was an easy init script. I've seen init scripts that span thousands of lines. And I mean, if you're not familiar with Bash and the simple programming that Bash can do, and right, I know, looking at that, it's not simple, then that stuff is overwhelmingly confusing. So again, this is really the reason why systemd has taken over. There's, like I said, there's a lot of furor over that. Systemd does a lot more than just starting up programs. It does a lot of stuff, and we'll kind of cover that as we go through the class. But let's get into it. System control. You are going to get very familiar with this command. Anytime you want to do anything starting and stopping wise of any services or targets, as in graphical mode, multi-user mode. Anytime you want to do mounts, the new way to do mounts. I'm going to teach you the old way because the old way is still very used all over the place. But the new way to do mounts, system control does that. And now we're getting into the stuff where init didn't used to do mounts, never did. It started services. That's pretty much it. System control is starting to take over things that other apps used to do, and this is why there's a lot of consternation on, let's just say, graybeards, folks that have been around for a long, long time in IT and already know how things work. They are not happy that systemd or system control is now taking over the jobs that other applications used to be, and they will talk about that's not the Unix way. And what they mean by that is every job is done by one tool, and that's it. One tool, one job, right? Systemd is a multi-tool. Think of like a Swiss Army knife, but more has the hammer and the screwdriver and the knife and the and a saw and everything, right? It's just systemd is an entire toolbox, whereas init did one thing, started things, and that was it. So there's a lot of conversation about that. If you dive in long enough, or if you use operating systems that are old enough, you will, I guarantee you, get into that conversation. And there's going to be someone around, if you have old systems like that they administer, they're going to tell you just how horrible systemd is. And I think a lot of times that just comes from, well, we always used to do it with init. Now we're doing it with systemd. And there's a lot of good argument for why systemd shouldn't do things that it does. But again, I mean, it's just kind of the state of Linux right now. And I mean, it's the way that it's run. So we got to get used to systemd. All right. So after all that fluff, let's talk about system services. So here's the point where I'm going to do this right here. So I showed you run level, and that would show you your init, your default run level. What I want to do here is the same thing. Another complaint about systemd is the commands are way longer. I mean, that makes sense, right? Run level versus systemd get default. If y'all have ever done PowerShell, system control tends to mirror those PowerShell commands a little bit in the length, because there's a lot of dashes. There's a lot of really drawn out things. So yeah. Anyway, so my default is graphical.target. I want to set that differently. I want that to be multi-user target. Set default multi. And here's the point where you can start to use the tab key. If whatever you're doing is really long, or you may just not know exactly how to spell it or exactly how it ends, you can use the tab key. Notice that. It just magically appeared on the screen. That's fantastic. Saves you a whole lot of time. All right. So this is Policy Kit. This is like UAC on Windows. It's like, hey man, you sure you want to do that? That's an admin thing. Oops. There we go. So you can see it linked a new thing. We'll talk about those links here in just a sec. What I want you to notice is where it linked that. That's an important directory. Etsy systemd system. I've got it written down a little further, but just be aware. All right, so what this does is it sets my default, and if I reboot, it does the whole thing. You get post, you get grub, you get the kernel handoff. There it is. Systemd is already started. It's starting to bring things up. You don't need to know any of this, by the way. The only time you need to really pay attention to this is when it says fail and it doesn't go any further. That's yeah. That's the time when you panic and you Google that exact thing right into Google, right? All right, so here's the deal, right? Same thing, I'm in a terminal, but yeah, it's a little different. And the reason I wanted to do this is just to save memory and speed things up a little bit. But that's what this does. So, I mean, the practical usage of this, isolate does it once, set default does it forever. Get default will tell you what you set it to. Now I know we're kind of going backwards, but now we'll talk about this one. So, services. Services are, as I mentioned before, I'd kind of defined daemon. A service is really just a daemon, and that is, again, just a piece of software that sits in the background and waits for something to happen. Whatever that might actually be. And as I defined before, cron D is a timing service. So, you schedule stuff with cron D. You want this command to happen or this set of commands to happen at 1 a.m., cron will handle it for you. So sometimes, for some reason, cron will die. It's very rare that cron dies. It's a very decent piece of software, old piece of software, and they've kind of gotten all the bugs worked out of it. But I don't know, if you abuse it, cron might actually die, and you'll need to restart it. So you can do something like systemctl status crond.service. Service. Oh, there's no cron D. Maybe it's just cron. I think Ubuntu. So one of the things that you'll notice though is that Ubuntu and everybody else tend to have, some have D, some don't. So if you see D at the end of any particular thing, just note that stands for daemon, and the D may or may not be found on the service. So what you can do, remember that tab key I told you about? So type in cron and just do tab. Oop, I hit it too many times. But it tabs out for me. Whoa, no. I do not want to see all 466 possibilities. But notice, so I'll do that again. Cron and then tab. And it'll fill out the rest of it for me. So, if you type it in and it's like, can't be found. Oh, I don't know what to do. Get most of those letters in there and start hitting tab. And that will help you fill out the rest. So anyway, you can see active running since a minute and a half ago when I rebooted. So we can then stop it. Now, one of the cool things is, notice when on cron, when I hit tab, it went straight to .service. If there was more than one choice, it would have only gone to the dot. And then if I hit tab again, it would be like, okay, there's a service, there's a target, there's a mount, there's a this and that and whatever. If there's no ambiguity there, if it's only a service, then you can just call it by its simple name like this, cron. And authenticate. And now cron should be stopped. So let's look at the status again. Now you can see, and it's active, it is dead. Yeah, I wasn't just being morbid. I mean, dead is really the status of a particular service. So anyway, I won't go much further into system control. Really, just get your run level or your target, and how to start, stop, and restart services. So the one thing I didn't do is start it. Systemctl start cron. Authenticate again, and we'll check it again. Systemctl status cron, and it's running again. So if you do want to see, it said 466 something different ones. It's gonna ask me. There are 466 services that may or may not be started on your system. If you hit Y, it will start. It will take you all the way through it, and you can see every single service all the way down. So, yeah, to answer the question, well, how do I know what services are on my system? Right there. That's how you do it. And all those services typically live in that directory that we were talking about a little while ago. So I'll bring that back up again. Okay, so these services, what about them? Here's how you write them. I don't need you to be an expert on these services. I really don't even need you to be able to write one. But I do need you to, if you are ever confronted with one of these services, know what some of that stuff means. So this is what one of these unit files will look like. And so by unit file, I mean this. So notice here, thermald.service. You're going to see this stuff in that file. And if we wanted to, we could make our own service. So usually what you'll do is you'll write the service in your home folder and then move it to where it needs to be. So we can nano. Let me see. What is this? Oh, yeah. Some HTTP server dot service. That's what we'll call it. You can name it whatever you want to. It does not matter. The only thing that matters is the thing after the dot. Dot service. That's important. Dot target. Dot whatever. Dot service is going to be the one that you'll find the most common, because what you want it to do is start up some application. You want it to do something. All right. So in here, in the very top, you'll have unit description equals some HTTP server after. Now, description is pretty self-explanatory. It doesn't matter what you put in here. It's to help you understand what you're doing. So let's say that this HTTP service is going to automatically start, but you don't want it to start until after the remote file system target is started. So what you're doing is you're saying, I know that this target is going to start. I don't want my HTTP server to start until that other one is successfully started. And then I've got in here SQLDB as well. And this makes a lot of sense if you want to, you've got a remote file store maybe to store the actual website itself or something like that. And then you've got a SQL database to store all the information in it. Maybe it's a storefront or something like that. To store pricing and changes and user accounts and all that stuff. So you want the HTTP server to not start until after the remote file system in SQLDB. So you don't even want it to even try until those things are up. Now, requires is another one that is kind of in that same vein, but the deal with this one is requires SQLDB.server. So the after thing is after it tries. So after it tries to bring up remote FS, after it tries to bring up SQLDB, then you can try to bring up HTTP server. But the requires basically puts in a requirement. If SQLDB.server is not running, is not on and running well, do not start the HTTP server. Right? Because, in our case, if it was a storefront and all of the info was listed in the SQLDB, the website's not going to work anyway. So, yeah, don't even bother starting the service unless SQLDB is running. There is a weaker version of this called wants. I don't have it in the notes, but I've got it here. I'm sorry, I don't have it in the example unit file, but I have it here. And these are ones that should be running. If SQLDB were to fail on start, then HTTP server would still attempt to start. And, that may not be a bad idea in a case like this, where it would say something like, SQL backend not found, or SQL backend can't make a connection with SQL backend, something like that. And that would give you an idea of how to go troubleshoot or something like that. So wants and requires, similar but not exactly the same. Require is a hard requirement. Wants is a nice to have. So we'll put that there. Now we start to define the service, like what you actually want to happen. So the unit file really contains information and how or what you need to happen before the actual service starts. Now, once we get into the service area, this is where we're actually talking about what needs to actually happen. So once all that stuff under the unit stuff happens, now what? So you've got so service right here, and then type. This is the type of service. So type is notify. And this will basically tell you yes or no. Did it start? Did it not start? This is what goes in the log. And then exec start, funky name for what executable do you want me to start? That's the deal. And then in this case, this is where our actual executable is. So user sbin httpd-server. That is the actual binary. So think about the binary as in Windows. It's the executable that you double click to start the program. That's the same thing. You're just telling Linux where it is. Now, once you save this, you can do Control S and then Control X to exit. You can move it. Let me see. systemd system. So if you move it there, and now I don't require you to know move or anything like that just yet, but let's say sudo mv this file. What is it? How did I name it? Some to etsy systemd system. Once you move it into that directory, I don't want to do it, but once you move it into that directory, you can start to control it just like any other service, just like we did up here. Yeah, start. Oh, here it is. Yeah. So systemctl whatever -serve.service. So start and stop and restart. Now we can actually get into some of the differences. So I showed you start and stop. Now there's enable and disable. So these are super simple. Enable turns it on and keeps it on. After a reboot, it will turn back on. If it's set to enable, to disable it, just swap it from enable to disable, run that. So I'll do that with cron. So let's check our status real quick. Make sure it's alive. Yep. So then systemctl. And you can actually see somewhere in here. Yeah, there it is. So if you look at this loaded line, my mouse goes away, so it's hard to tell you, or hard to show you exactly. But look at that loaded line, and then go all the way to the right. And you can see enabled, vendor preset enabled. So the first enabled means that's its current state. The vendor preset means that's the default state. So the vendor preset doesn't really matter. It just reminds you how it was set when you installed it. That first enable is really the thing. So let's do systemctl disable. Now keep your eye on the birdie. I'll show you again. So systemctl disable cron. This will stop it from starting automatically on boot. Oops. Maybe I should type my password right. Oh, what? Oh, cron's probably not a good example to do that with. So anyway, so disable. I think systemd is preventing me from disabling cron because cron no. But services that you control, disable will work, and it will set right here. That cron service semicolon enabled will flip to disabled. It'll stop. Actually, you know what? I have SSH. Let me just do SSH. That's I think that's why I have it in the notes. Let me see. I don't even know if I have it. Let me install it real quick, and then we'll play with this one. This one will actually allow me to do it. It's not inextricably tied to the system. And you want cron starting on boot because you can also tell it to on boot stuff. Doesn't have to be a service. It could just be a couple of commands or something like that. So all right. So let's play with SSH instead. Status SSH. Okay. All right. So same deal right there. Look at that loaded line. It has enabled. Oh, cool. I can maybe do that. Anyway, enabled vendor preset enabled. Right. So by default it's on, and currently it is on, so let's turn that off. Oh wow, I guess I just have to use sudo with it. Systemctl ssh. Oh. There we go. Okay, I just had to do it as root. All right, so at this point, status, notice that loaded line. So lib systemd system ssh.service semicolon disabled. So that right there is telling you SSH will not boot or will not start on boot. And to fix that, enable. All right, so when you're enabling and disabling, make sure to use sudo. Otherwise, it yells at you. Now, that may not be the same in CentOS and OpenSUSE. The thing that the whole reason that I have you running 3 separate VMs doing the same exact stuff across all of them is simply because each distribution does things a little bit differently. Now, CentOS or OpenSUSE might allow you to do that without using sudo at the beginning and just use pulkit, which is the thing that asks your password, to just authenticate you and let you do it. And Ubuntu obviously does not. All right. So this is pretty important. So let's say that you have a service enabled, but for now, you just want it to never start regardless of whether someone comes in and starts it or stops it or enables it or disables it. You just need to make sure this thing is off and stays off. So think of a situation where you're running a backup and you know that there are scripts in the system that will automatically enable SSH, right? That if it's off, turn it on. So you know that those exist, but you do not want them to work. You are running a backup and you do not need anything on the system to change, so you boot everybody out of the system, you turn off SSH, and you want it to stay off. That's this. So enable and disable, start it and stop it on boot. This forcefully keeps it off. So mask will forcefully keep the SSH service off. So if you just really do not want SSH ever turning on, you'll do this. So you can do, right? And so what it's doing, look at this. DevNull is a fun place. It's a black hole. So what it does is it linked the service to DevNull. So anytime anybody tries to start or stop the SSH service, it's going to give you an error that says something about DevNull. And DevNull, quite literally, they call it the bit bucket. And really what that means is that's where you throw bits or anything, really, when you want it to just poof out of existence. So the SSH service is now inextricably linked with DevNull, which means it won't do anything, ever, at all. So to fix that, you just unmask. Sudo system control unmask SSH, and that will fix it. All right. Right. So if you go in and mask cron or something like that, yeah, your system might end up weird. All right. So I told you we wouldn't go too much further. I just need you to know some names. So systemd. So target files and service files you know about, right? Target is like graphical target, multi-user target. Mounts, and services are, the SSH service, the remote control service. Cron, the timer service. Mounts. This is like if you have secondary, third, fourth, fifth, sixth, seventh, eighth hard drive, and you want it to automatically mount, or you want it to at least be able to, you want to start the mount, stop the mount, stuff like that. You'll have a mount, and those mounts look just like this stuff as well. It does make them fairly simple. And then as we were talking about requires and wants, these basically turn into be directories. Let's just look at it real quick. So etc systemd system. There we go. And then you can see all these wants. So let's look at graphical.target.wants. And you can see if you're starting up graphical target, it requires everything before it. So whatever multi-user.target wants, because it's a lower level thing, it'll do all of that stuff. And then graphical target also wants accounts-daemon and udisks2. And then there's requires as well. So open VM tools. Let's just see what's in there. Open VM tools.service.requires. And then you can see right here, it requires the VG-auth service. And then you can see where it really lives, this lib systemd system VG-auth.service. So there are a couple of places that these services can live. Lib systemd system is usually where you'll put your stuff. There's also another one in USR, but for testing purposes, typically this is where they're going to ask. Etsy systemd system. Those are the main services, main wants, main requires that this is where they live. All right. Last couple things about systemd. Systemd analyze blame. So if your system is booting slow, you'll want to do systemd analyze blame. I don't know if I can do this without sudo or not. Oh, yeah, sure enough. So this puts you in a situation where at the very, very bottom, the very first things after the kernel starts loading, or after the kernel is loaded, this is what comes up. After the kernel and systemd are loaded, this is what comes up. So you can see Plymouth set VTRGB, Plymouth quit, says kernel debug, systemd update, and in order. Each of these services come up in order, over and over, and it tells you at what point in the boot it took. So if you saw cloudconfig.service happen at 1 second, and then the next service, let's say modem manager it is, and it says 30 seconds right there, you know there's a 29-second delta, a difference between those two services. And you need to investigate why in the world modem manager.service is slow, why that is. So you need to investigate. So systemd analyze blame is basically, what do I blame for this long startup time? That's really when it is, what it is. So that becomes pretty helpful when, for some reason your system is coming up a little slow. All right, here are your targets. We talked about those earlier. These are like the init run levels. There's power off, which, power's off. Rescue, which puts you in the rescue mode, just like init 1. Multi-user is like init 3, so what I'm in right now, just the command line. Graphical, you get the whole mouse and, menus and all that other stuff. Reboot, and you'll use the system control isolate command as I showed you above to do that. So system control isolate, whatever one of these you want. All right, and honestly, power off is just usually what I use to power off the system. You don't have to use systemd to do that, but really what it's doing when you're typing in power off is asking systemd to do it. It's like a shortcut. Some of the things that you'll run into that I do not require you to know right now, just know it exists. Hostname CTL. Hostname CTL will do things dealing with your hostname. Hostname control. So let's just show you how it works real quick. Set hostname, and we'll call this, how about Servy? Because why not? So nothing actually changes immediately. It'll all change after a reboot. So I'll reboot here in a little bit to show you what's going on. And then journal CTL. I'm going to ask you to do this a bunch. Journal CTL-XE. So you come and tell me, hey, I don't know what happened. I started this service. It said it started, but it's not working. I don't know what's going on. This is the command I'm going to tell you to run. Journal control-XE. And journal is basically just the journal. This is the log. This is all of that stuff. And you can actually see today, the clock is wrong because it's set to UTC time, not -6 like we are, or -6. You can see, if you read that line, system hostname changed to Servy, and change the static hostname. Hostname changed from, and you can hitting the right key, and you can see here hostname changed from Ubuntu serve to Servy, and you can see all of the things that happened to make that work. And yeah, you can see the units a little further down, getting the memo, all that stuff, right? So all of this stuff starting right here is related to what I just did. So that's the cool thing about Journal Control XE. It shows you the last thing that you did or the last thing that happened, and you will see red and green and blue in here when it needs to draw your attention to stuff. But you can go up and 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 see all kinds of stuff. Anyway, so you'll usually just work backwards until you find whatever it is that you need. So hit Q to get out of there. Anytime you have a situation where you've got this right here, it's telling you where you are, and as you move, it kind of keeps track and tells you. Hit Q. I mean, really, if you're running anything and you don't know how to get out, try Q first. Q for quit, and that will likely work. I'm going to show you top and H top here in a minute, and that's how you get out of those two. All right, so that's it for System D. Controls all the things. It's one big puppeteer. It's what it does. So now we need to actually go see, a lot of times in real time, what's going on the system. So think of what we're about to talk about a lot like Task Manager in Windows. So it's a lot more rudimentary because remember, a lot of this stuff was built in the 70s and 80s when Unix was just in its infancy. So yeah, a lot of these commands are very basic. And again, that Unix philosophy I was explaining to you before does one thing, period, does one thing. And PS shows you processes. In all the ways that you ever want to see them, PS shows processes. That's it. That's it. It doesn't kill processes. It just shows processes. So there's a command for killing, and that's kill. So yeah, that's the Unix philosophy. Break everything apart. Everything does one job. And we're getting away with that with System D. So that is that conversation. Anyway, so PS, just by itself, will show you what's running in the current terminal, which is the current terminal. The current terminal is actually called bash, the born-again shell. And you can see PS. So, yeah, PS does show itself when you're running itself. Yeah, there's a lot of that weird inception-y stuff going on in here, but that's the idea. So, yeah, so you see PID, that's your process ID. TTY, that is the terminal that you're running it in. If you noticed, you may not have, right at the very beginning, before I even logged in, it defines to you which TTY you're in. So I'm going to swap over one, and you can see up here on top, TTY2. So if I were to log into this and run PS again, you would notice TTY2 underneath that TTY. So it's just basically telling you where that's running. I'm going to go back to TTY1. And you do that with Control, Alt, F1, F2, F3, F4, F5, F6, F7. And that corresponds to TTY1, 2, 3, 4, 5, 6, 7. So you don't need to know that yet, but that's the deal. Yeah. Right, okay. For a second, I was like, I'm in the wrong thing. I'm not. That would have been a lot of time wasted. Anyway, so PS, right? Shows you processes. Now, you really just want to get PS to start asking broader questions, right? So running it with the -A option will show all users' processes on the system. And there's not a whole lot, right? We're not doing much. But let me move over here. Let me actually log in here. And let's say, well, let's just run top. We'll come back. I'll explain a lot of what top is doing. And you can see now it's giving me a little bit more information, right? Still telling me bash and bash. That's to be expected. I'm running bash. In TTY1, I'm running PS, and in TTY2, I'm running top. So your user. This is referring to your user, not well, right, stuff that you have started. So that's the deal. So you can do PSAU, and that will expand out the information and even give you a little bit of this root user information. You will say all the things that users have started. Root, as the super user, started some stuff. So, all right. So here's the deal. I've got a legend down here at the bottom. So we can look at this stuff. User, PID, CPU, mem. All the way at the bottom. Yeah. This is going to define a lot of that stuff. So process ID, right? This is the one that if you're going to stop a process, this is what you need to know. Parent process ID. So if you start a program and then start, well, think about it like this, right? Everything is running in this bash terminal. So top is running in my TTY2 bash terminal right above it. So if I were to kill 2552 right there, all the children processes would die with it. So top would die with it. So we'll look at this a little bit more in depth, but you'll see htop will even draw you a tree. I think top will as well. User ID, your user ID. TTY, which TTY you're running, priority, nice, CPU time. So there's a definition for all of this stuff, and I'll bring them up as they kind of become necessary to talk about. A little further, a little further, a little further, a little further. There we go. All right. So adding X says not just user information that are running in TTYs. Give me all the stuff that wasn't manually invoked. So notice I've got TTY1 and 2 and 2 and 2, and then there's question marks as you go up. That just basically, all that question mark means is I don't know what TTY it's in because it's not in a TTY. And notice, right, the systemd user is running stuff. Message user, syslog user, daemon user, avahi user. So don't worry too much about that at the moment, but just know that there's a user for just about everything. And that question mark basically just means they didn't run it in a terminal. The system itself started it. And then F. Now this is what's going to help us see that tree, that hierarchy. So let's take off X and add the tree. So notice root did a bin login, allowed me to log in. That's why it shows up here. Then the child process of that is bash, and then the child process of that is top. So if I were to kill 2465 right here, it would kill this one and this one as well, as they are children processes. And then same here, right? Root let me log in. I'm running a terminal, and this was my PS command. So this is no longer running likely, because PS basically just, it does a thing, and that's it, and it goes away. But bash is still running, so if I were to kill this one, I would lose bash. All right, so that's the basics of PS. It shows you stuff. We're going to learn how to manipulate PS way better. There's a command that you can give all this output to, and that will essentially search. So if I wanted to find anything that the root user was running, you can do stuff like that. Top can do that too, but searching sometimes your brain is just like, show me all the stuff, and I'll search for what I want instead of trying to remember like, was it X or T or L or F? What option was that? Right? It's just sometimes it's simpler to just give me all the info and let me search it. All right. So free. So PS is going to show you information about processes. Free is going to show you information about memory. So by itself, it shows you bytes, how much memory is used in the various situations. But I'm going to tell you, it's unless you need some extremely granular answer as to how much memory you're using, and hint, you probably won't need that often, you always want to run free with the -H option. And this will make it a lot easier to read, right? Memory, total. So look at that at the top row, not the bottom row. That's what I'm talking about. And sorry, I would use my cursor, but I cannot. it disappears. So right here, the 1.9 number, look at that row. So that's the total amount of memory that I have on the system. 139 megs is how much is used. 1.4 gigs is how much is free. 1 meg is how much is shared. So in the very first lecture, we were talking about libraries and how all the software tries to use, tries to recycle that one library. If I share code with another software, we're going to both use that same library to cut down on system resources. This is how many or how much memory those libraries are taken up that are shared. So if a library is being used but it's not being shared by anybody, then it does not count here. Now, buff cache. Now this is how much memory is being used. It's trying to anticipate what you're going to be doing. So you started SSH, there's a good chance that you're going to need other processes that you haven't invoked. You haven't told them you haven't told the system that you want it to come up. But Ubuntu knows that, okay, SSH is running. The first few things that a lot of people always do after they do SSH is this. So it just goes ahead and adds it to memory so that whenever you invoke it, it's fast. Windows does this as well. I do forget what they call it, though. Anyway, so you'll see available 1.7 gigs. That's how much memory is available to the system. And that mostly tracks with the used memory. So 1.9 gigs minus 139 megs is approximately 1.7 gigs. But sometimes you'll see some discrepancies, and a lot of times that's because what it's doing, and actually, no, I take that back. When you do that math, it doesn't really track. What it's really doing is it's adding up used, shared, buffers, and cache, subtracting that from the total, and that's what you have available. So something like, what is that? 600, almost 600 megs, something like that. Anyway, that's the idea. And then swap is virtual memory. So in Windows, when you run out of memory, it starts writing to disk. Y'all should have covered that in the operating systems class. That's what swap is. Swap is the same name, same thing for virtual memory. So I have 2 gigs, same as my memory, which is typical for Linux, but none of it is used. So I've not run over my amount of memory. Dun, 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 dun. Swap plus. Oh, total. Right. So if you add the T. And by the way, if you have noticed, I'm not retyping these commands. So just like tab, the up and down arrow keys, they'll save your life. So if you hit up, it lets you scroll back through all the commands that you've run today. So I'll go all the way back down. So from an empty terminal, it remembers that I didn't even press enter on this one. It remembered that I was working on this command, so it brought it back up. And if I go back one more, yep, free as I ran before. All right, so HT. And that just gives you the total line down here. Right, so total memory, including swap, I have a little bit under 4 gigs. Total use, total free. That's the idea. Okay. So let's say a process is using too much memory or too much CPU. It's choking off the system, and we need to fix that. You do that with kill. So I had mentioned that you can kind of really just gather stuff. And this is a bit more of an advanced topic, so I don't expect you to remember this one because we'll use pgrep here in just a minute to make that way easier. So well, you know what? Let's just use pgrep now. So pgrep is basically a process searcher. If you know the name of the process, you can type it and find out the process IDs of all the bashes. So the downfall of, well, not really downfall. Yeah, it'll give you name. Did I type that right? Yeah. So we can get, parent ID. If you want to search by parent ID. But the idea a lot of times with pgrep is that a lot of times you're only running one of these things. So think of like a browser, and you are running Firefox or Chrome or something like that, and you just need to figure out what process ID Firefox is running. I mean, this won't come back with anything because I'm not running Firefox, but you do that, and it'll say these 3, and then the next step would be to say the process ID was that and that and that, and then you'll just say kill. So kill automatically uses SIGTERM 15. All right, again, super old. That's why these are like this. But sigterm 15 and sigkill 9, these are the ones that you're going to be most familiar with because if this doesn't work, this will. But you typically want to do this. All right, so think about it like this. Sigterm is basically like clicking the X button on the window, right? If you've done that in Windows and the application is like, I'm not even responding to you, it does not forcefully kill it, right? It like in Mac, it'll gray out the screen. I think in Windows, it'll do the same thing. Linux, it will gray out the screen, gray out that app, and it will basically say, do you want to wait for it or do you want to kill it? So if you say, I don't want to wait for it, I want to kill it, what you're really doing is this. So sigterm 15 is the default, basically pressing the X button. So when you say kill process ID number 1441, you're pressing the X button on that process. Now, if it doesn't die, then it's something is happening that is preventing it from going away. So assuming you know that you need this thing to go away, there's just no doubt, it needs to be gone, then what you can do is tell it the signal that you want. So 9. So 15 is default, so you don't have to actually say it. You can say kill-15 1441, but I mean it's the same as just saying kill, so no need. But let's say, all right, I'm tired of your business. Let's just kill you. You're done. That's how you'll do it. And if you do not own that process, so if you turned on Firefox, you own the process, this will work. Let's say Firefox's process ID was 1441. We did pgrep, and it said 1441. And we're like, all right, cool. Kill 1441, kill 9, 1441. If you own that process, if you started it, this will work. If it's somebody else's process, you're the admin and you need to kill somebody else's process, you need to use sudo or sudo. So, same thing, sudo kill 9 1441. I'm not going to do that because that might actually be a process that's in use, but that's how you'll do it. Yeah, pgrep is fantastic. Use it to find things by name. And it will, pkill. So what you want to do, you always want to do pgrep first and pkill after. And pgrep L is nice, as in there might be another program that has bash in the name, like bashify or something like that, right? And you don't want to actually kill that one. This is why you want to do the -L. And you're like, okay, cool. Those two processes are named bash. I do want to kill them all. So what you'll do is pkill bash. And whatever pgrep brought back, that's what pkill will kill. Pkill works the same as kill. So if you need to forcefully do it, that's how you'll do it. Pkill 9. And again, as long as I own both of those processes, they are my processes, Leo's processes, then they will die. All right. So jobs. Jobs are basically things that are still going, that are ongoing. So in the lab, I'm having you basically run less, which is a thing that will. Oh, that's right. I created a file. That's perfect. So we'll use our service file for this. So what we can do is less some HTTP server service, but right, like I can interact with this. This is something that's running in the terminal. One thing that you can do is Control Z. When you hit Control Z, I know it says stopped, but that's basically it stopped it from doing stuff. So essentially pausing it. So a Control Z will pause, and that's got a signal as well, which is 20. So it's like we did like kill 20 to this process. That would be the same thing. And that's basically it, right? You can pause it. Like I only have one terminal. I'm going to pause this for now. I'm going to go do something else real quick, and then I'm going to come back to it. Well, how to come back to it is FG. Notice there's a number here. Right there. So we can bring it back, right, with FG. Let's pause it again. This time, I want to create a new file. Let's just call it file. And I start typing in this, start working and doing all that. And I'm like, you know what? Hold on. I don't want to save. I don't want to do anything with this yet. I want to push this to the background for a minute. You can do the same thing. Pause or stop and notice it has a number, right? So the deal with this is that you can type in jobs and see, okay, cool. So one job is less that file. Another job is text editing that file. Okay, cool. Notice the plus. That is the default job. What that means is if you just type in FG, now FG stands for foreground, it will bring background jobs to the foreground. FG by default will bring back the one with the plus on it. So if I do FG, Nano should pop back up. But let's say I didn't want, here, let's do it real quick. Yep, there's Nano. Control Z again, push it to the background. But let's say I wanted to not bring back Nano, I wanted to bring back less. I wanted to check that file because, maybe something in that file will impact what I'm typing in the file that I'm working on. You can do FG %1, and that will bring back your other file. So think of this like Alt-Tab in Windows. That's what this is. That's what these jobs are. You can continuously run a bunch of different jobs in one single terminal and keep pushing them to the background, bringing them to the foreground. Use jobs to remind yourself, okay, these are the jobs that I've got running, blah, blah, blah. That's what we'll run another one and push that one to the back. We'll run another one and push that one to the back. And then, look at jobs. All right, we've got all those jobs. So 4 is the default. 3rd will be next. Or 3 will be next. So if I do FG, top will come back. Yeah, all right, so push that to the background again with Control Z. Say I want to mess with my my text edit. That was number 2. Let's go back in here, type some more stuff. Push that to the background. I want to, and notice, by the way, the last one that you did becomes the default. 2 is now, here, I'll show you. 2 is now the default. So if I do FG, it'll bring Nano back. But let's say I don't want Nano. I want my text file. Let's look at that. Right? So that's the idea. Now, again, remember, when you have this little thing down here, Q to quit. Let's look at jobs again. Now it's missing because I killed it. So let's FG %4, top, Q to quit that. Look at jobs again. It's all gone. Let's do FG number 3. H top, kill that. Q. Jobs. And just one left. So at this point, we just hit FG. We can save this file, do whatever we want to with it. I'm not gonna. I'm just gonna know to save it. And then jobs. Nothing. That's it. So jobs is a way to multitask. That's the idea with that. Push it to the background with Control Z, pull it back with FG if there's only 1 or 2, and then this is how run jobs to find your list, FG %, and then whatever job you want to bring back. That's how to isolate just one and pick it out and start working on that thing. So nice is a way to give more priority or less priority to a process. So think of it like a backup job. And you don't want that backup job to be slowed down for anything, right? I want this to be the most aggressive it can possibly be. I do not want anything to interrupt it. If anybody tries to interrupt it, they will get CPU time slices that that are left over, but they cannot have any that this backup job wants. So what you will do? So let's say there is not, but let's say there's a program called backup. Oh, there actually is. Open AFS-client. That's funny. Anyway, let's just say that we're using a program called backup. If you do this program, you will notice that the nice is typically 0. So to demonstrate this, I'm going to use htop real quick. But look here. This column where it says "in-I," look just a little bit down. Sorry, my mouse disappears. But it's this column right here. And notice pretty much everything is 0. And that's default. That's good. -1 is I know, just bear with me, a higher priority than anything with 0. Here's the way that you can tell that -1 is a higher priority. Look right here. The next column over to the left. It says PRI on top in that green bar. That stands for priority. The closer to 1 or 0 that you get, the higher the priority. So this right here is the pretty much the de facto how much priority does it have, right? So a priority of 1 is pretty amazing. Or priority is 0, really. That is the highest priority that you can have. And then so priority 39 is the lowest priority. So the way that we interact with that priority, though, is through this nice value. How nice do you want it to be? So the way that you can think about this is the least nice. That is the least nice any process could possibly be. It will get a priority of 0, which means that it ignores everybody else's pleas for, I need CPU time. I don't care. Do not care. I am not nice at all. Right? So you can, the scale of niceness goes from -20 all the way to 19. Right? And so mathematically, that makes a little sense, right? You know what? I'm going to get rid of that dash because that's confusing. So -20 is the least nice. You have taken all of the nice away from it. -20 is the lowest number you can get. 19 is the most nice. That's as many nices as you can give to it. So it will get a priority of 39, basically lower than everybody else. So if it's the most nice, think of it like you know what, there's a long line of people going to the grocery store and you feel like, yeah, I should open the door for this one. But there's always that one person that's just close enough that you feel like you're kind of obligated to keep that door held open for them, right? That's a niceness of 19. That's what you're doing. You're like, oh, yeah, no, go on ahead. Right? And then, you make them do that little, that fast walk run thing that, oh, thanks for holding the door. Let me, and you're like, no, don't worry about it. No big deal. I'm not in a hurry. You know, that whole thing, right? You're being nice. You're being 19 there. You're being a niceness of 19. But, yeah, so a niceness of 20 is not even not opening the door for people. It is closing the door behind you even though you know there are people behind you. That is the exact opposite of holding the door open for people, right? And so priority of 0, when you see that, is basically I don't care about anybody else. Priority of 39 is I care about everybody else more than myself. And anything in between, basically. So if you've got a priority of 20 and then a priority of 22, then the priority of 20 is going to move ahead before the priority of 22. So they are basically inverse. So the higher the priority, I mean, that makes sense, right? If the priority is 0, you are the highest priority. Priority of 39, you are the lowest priority. Nice is how we interact with that. And if you notice, if you add up the integers, ignore the negative for a sec, add up the integers, you end up with 39, which is the lowest priority that you can have. 0 is the regular niceness, the baseline. Anyway, all that to say, you can re-nice things after the fact. So, as I mentioned, you don't want that backup to be interrupted at all. So you'll run it as a niceness of 20. But if you do a negative value of any kind, you have to run it as root. Negative value, you cannot, as a regular user, make anything a higher priority than like systemd. And systemd has a priority of 0. Or I'm sorry, a nice value of 0, priority of 20. So so to make something a priority of 0 as well, I keep getting those back and forth. If you want to, oh no, I'm sorry, that is right. A priority of 0. If you want to make something a priority of 0, the most important process, you need to run that as root. But anything in the positive values, say you want a nice 5, you do not need sudo for that. All right, so let's say we're running something. So here's what we'll do. I'm gonna run. Oh, I think yay, top is still running. Okay, so it's still running in that other terminal. So I'm gonna use this. So let's look at. Let's find top. So the cool thing about htop, this is why I wanted you to have it, is because you can look at stuff. You can even search. So notice down at the bottom F3. I'm gonna do that, and I'm gonna search for top. And that's htop. That's not the one that I care about. So I'm gonna hit F3 again for next. Oh, there it is. See, and then it toggles between the two that have names with top. So notice it's nice of 0, priority 20. That's default. That's normal. So let's say we want top to be more nice. We want it to, let other processes have CPU time before top. You don't want top to interfere with anything. So that is process ID 2564. And just to remind myself, pgrep top 2564. And then we can do renice. So the number that I want it to renice to, and let's say 5. The process ID I want to renice is 2564. And you can see that worked. Old priority 0, new priority 5. Let's do htop again. Yeah, and then you can see it right there. So I'll even highlight it for you. Right there. Top. So a niceness of 5, priority 25. So I've made it more nice. So its priority is a bigger number, which makes it lower on the totem pole. And as a matter of fact, you can do the niceness if you look down right here. You can do that within htop, which is kind of fancy. But I need you to know how to do it manually, so we'll do it manually. So 2564, just remember. So let's see what happens if I try to give it a negative value. It's going to yell at me. Let's say I want it to be -5. So I want it to, not hold the door open for other people. Process ID of 2564. Cannot do it. Permission denied. All right, so let's do that again. Sudo renice in 5 P2564. There we go. So you had to do that as admin. And we'll check htop again so you can see it. F3 to search. Top. And there it is down there. So niceness of -5, priority 15. So that priority moved it up the totem pole. It's closer to 0. So that's how you'll do the changing of the priorities. Typically, you won't be using htop. You usually have to do change. What do you call those forms? Basically, permission to make changes to a system. Anyway. Sometimes you will, sometimes you won't. Depends on where you work. Anyway, and yeah, that just a reminder. Nice values below 0. So what you'll typically get is top. So, but let's just move over to our second terminal where we're still running top. Top has been running this entire time. And really, top is pretty good for just really dealing with anything. Top has the same feature set as htop. It's just not interactive. You can't use arrows or anything like that with it. So press H, and it will tell you all of the keys for all of the things. Here's how you're going to do all the things. And this is why, again, I really enjoy htop because it's super simple. Everything shows you whatever you need to see right there on the screen, and you can deal with those processes that way. So it just makes things easy. Anyhow, Yeah, keep those in mind. I've got some important ones over here. K and R. So this is what we've been talking about this entire time. If you do K, you can say K, and notice right here, whatever the top process is what it tries to kill. Killing process ID 1, again, is bad. Don't do that. You wouldn't be able to anyway because you don't even own that process, but it's not the point. Just don't. Anyway, and then R will renice. So let's do escape to get out of that and do R instead, and it'll say, which PID do you want me to renice? And so 2564. And then what renice value do you want? Let's put it back down to 0. See if it'll let me. Yeah, sure enough, there's top. On top, nice value of 0. So the same things that we were doing in the command line, you can do in top. Top is always installed on every Linux system. And if you need, if white's not your thing, you can, not H, Z. We'll add a little bit of color to it, maybe make it a little easier to read. Add some contrast to it. So you can change the colors. You can actually go in and configure what colors you want that to be, but that's not important for the class. Anyhow, all right, so no hup. So no hup is a way to do something in the background, and it will notify you when it's done. So it's kind of like doing Control-Z, except it doesn't pause the process. If you do Control-Z, it will pause everything. So if you're downloading something, it will pause it. And then, when you bring it to the foreground, it'll start downloading again. Well, a lot of times you want a process to continue happening in the background, but you don't want to open up another terminal to do something like that. So no hup is what you want. This is an example. This does not actually exist. Don't try to do this. It will tell you download failed because, can't find it. Let's see. I think you can download something here. I don't want a Mac one. Can I get the Linux one? There it is. Cool. Let's get the tar-gz. What I want from this is not... No. Show me the downloaders. Okay, how about not? There, downloads. This is what I want. I want this link. Actually, I can't download that link. I can't copy it. Okay, so what we'll do is no hup. Yeah, wget. So wget is basically a web getter. It gets things off the web. And then we want, let's see if I can type all this out right. Discord app.net apps Linux 0.0.13 Discord dash. Okay, assuming I spelled all that right. All right, and then we'll put an ampersand at the bottom or at the back. So what the ampersand does is whatever you're doing, that's fine. Put it to the background. No hup though says do not hang up. Don't stop the thing at all. So we'll do that. And now we can do stuff, whatever. Oops. And then notice right there, it is done. It finished. So let's say that was, a 7 gig file. That would have taken a long time. And then it would have come back and be like, all right, done. It would have told us that. And then we can see, there we go. There's our Discord file. It did download after all. So do not hang up, even if I push it to the background. The command I want you to run is webgetter. The file, again, not that example, but say, this one. And then push it to the background immediately. So that's basically like doing Control-Z. But again, no hup says, just keep going. Just keep doing stuff. All right. So the last thing that we got is screen. Last thing, I promise. The video will totally be over after this. Oh, wait. No, I gotta tell you about the quiz. Well, the lab, really, I guess. And that'll take maybe 2 minutes. So anyway, screen. So we've been talking about doing a bunch of things in one particular terminal. Screen is going to be a way to do that. On CentOS, on CentOS, on CentOS. You did this last lab because that's how you got HTOP. But if you didn't, if for some crazy reason you got lucky and were able to install HTOP without doing this, you need to do this. This installs the repository that contains HTOP and screen. So if you do not do this first, it's going to be like, screen, what program is that? I don't know where that is. You can't have it. So make sure you do this first. So screen. Screen is a way to run multiple terminals inside of one. Yup, kind of like a VM, but not really. It's all in the same machine. But you're running multiple terminals. So let me explain. So I don't think I have screen on here. Oh, I sure do. It's already installed on Ubuntu. So here's the deal. If I hit exit, normally that would log me out. But notice here what it says. Screen is terminating. So that's not normal. So screen is a way to get you another terminal. But if you look at these options, you can really just create a bunch. So here's the deal. So let's do screen again. And notice at the bottom, if you're just running screen by itself, just the command by itself, you got to hit space or return or enter. And now you can run commands. I mean, and this is, same stuff as before. You can run all the commands, list all your stuff, do wget. You can get your cat picture archive if that link were real. Right, so we can do that. Now, here's the cool thing. You can create a new screen even in the middle of a job. Like this. You don't have to push to the background or anything like that. So here's what you do. Control A, then, that's what this comma's about. Do Control A and then release everything. And then press C. So Control A, then C. And it will create a new screen. That old job is still running in to the, if you want to imagine it, to the left. It's still there. But now I've got a whole other terminal that I can use to do some other stuff. Here's the output of my download. You can see it gives you an update every 50 kilobytes. And down 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 and down, right? So that's cool. So Control A again. Oops. Control A and C again will get me a new screen, and I'll run top on this one. Control A again and in. Oop. Oh, not in. Control A and C. That's what I get for pressing the wrong key. In goes next. C creates. And I'll run HTOP. Okay, so here's the thing. Control A in will take you to the next one. Control A in will take you to the next one. Control A in. Control A in. So the one I was just on was regular top. So let's go back to that one. Control A P for previous. Right? So Control A in for HTOP. Control A P for the previous one. So back and forth and back and forth and back and forth. And here's where I'm getting at. P and in. Control A D will knock you out of screen altogether. And then it will tell you, oh yeah, I guess you could just do that. Don't lock it, mostly because you have to set a password in ScreenRC first in that particular file in your home folder. So don't bother with the locking. You can just detach. You're the only one on this machine anyway, so no big deal. So Control A D will detach us. And notice it was 2675. So if you remember that, you can go back to that screen ID. Or you can just do screen ls. All right. And then we'll reattach to 2675. There we go. We're back in the screen. So now I'm done with this. I don't need these screens anymore. So I'm going to quit out of top and then Control A K to kill a screen. Really kill this window? Yeah. And then quit HTOP and then Control A K. Really kill that window? Yeah. Same thing. Quit out of that. Control A K. Yep. Quit out of that. Control A K. Yep. And then you can see all of my screens are done. Screen is terminating. It's over. So it's a way to get multiple terminals going in one single terminal. This is very important in situations where you're remoting in to the server, and the policies and permissions are set such that you can only have one session open. Period. That's it. So Screen will allow you to, basically do multiple sessions. There's a way better way to do this, but Screen is on the test, so I need you to know Screen. Tmux is way better at doing this. You can actually do like multiple screens on the same screen. So you can have like a terminal top left, terminal top right, terminal bottom right, terminal bottom left, and you can just, I think it's like control and then your arrows to move to the different terminals. It's super nice, way easier than Screen, but I need you to know Screen, so we'll play with it a little bit. All right. So don't forget to install EPEL release on CentOS to get Screen. And then here's your legend. So we were looking at top and HTOP and PS. Here are some of the most important little abbreviations that you'll need to know. So we've already talked about pretty much all of this stuff, right? Swap and how much memory something's actually been using, the nice value, priority, the terminal that has been running on, process ID, things like that. So this is just to give you a better idea and to connect the dots with that the abbreviations that you have up in the top row a lot of times. So keep that in mind. Those are pretty important. We've done it. We've made it. Thank you for hanging out with me this long. That was a long one. I know. I am sorry. There's a lot of stuff to cover. So anyway, these jobs are these particular labs. I am not asking you to do anything in these labs that I did not show you in the video. So, yeah, use a little key. Speed me up. By the way, this video is going to be massive. So speed me up. Put me on like 1.25 or 1.5 so you can get through the video a little faster and hopefully find what you need. So anyway, so on Ubuntu, you're just going to run your updates, but you're going to pause it in the middle. It takes a little while, so you have plenty of time to do Control-Z. But anyway, so Control-Z while it's doing stuff to push it to the background, and then you're really just going to play with the jobs. Show it, kill the process ID. Don't forget, this is probably going to need to kill 9. It doesn't like to stop while it's in the middle. Use pgrep like I did a little while ago. CentOS, this is mostly about Screen. So install and launch Screen. Play around with the screens like I was showing you a second ago. Control A and then the letter to do N for next, P for previous, C for create a new one, and then run a few commands. And we're gonna change the nice values of stuff, and then you'll kill all your screens. And then in OpenSUSE, you're gonna install OpenSSH. So remember, do zipper with that. Zipper install OpenSSH will take care of that for you. And then we're just going to play with the service, find out what the status is, enable it, start it, stuff like that. That's pretty much it. So each time you do something, you're going to take a screenshot, throw it in a PDF, call it a day. That's pretty much it. And your quiz comes out of the video, comes out of the notes. So if my recommendation for quiz every single time is have the quiz open while you're watching the video, and then whenever you find the answer to the thing, put the timestamp in the question, and then because there's no time limit on those quizzes. You can work on those as long as you want to, as long as it's before the due date. There's no real time limit on it. So write out all the questions on a little notepad. Put the timestamp of the video or location in the notes or something like that, and then that way you can go back to it and answer it if you just want to keep watching the video. Otherwise, pause me, write the answer, play me, and we'll be good. Okay, well, that does it. That certainly does it.